Oh, good afternoon. I'm Timothy Precella. I'm here with my Math 1314 class, and today we're going to be looking at factoring. And remember, y'all, you have to check. Even if you don't watch the videos, you got to click on them to get those green checks. And at that point, the problems will light up and you'll be able to access them, okay? Mm-hmm. Now, there's a little bit of talking Tony wants to do first. Mm-hmm. Hold on. Move that paper down a little bit.
I want to review something that we were doing last week. FOIL. Suppose we had 5x minus 7 times 2x minus 3. Okay, 5x minus 7 times 2x minus 3. This isn't anything new. We were doing it last week, but instead of x's, what variables do we have? It's one letters. What letter?
I.
That's I, yeah.
We had i's instead of x.
So let's see. First, 10x squared. Outer. Is that a minus 15x? Inner, minus 14x. And then the last, is that going to be a plus 21? So first, outer, inner, last. Here we have some like terms. Remember the last time we had those I squares and we had to replace them with -1? None of that today.
These letters are just variables.
So first, outer, inner, last. Which of those can be combined? Well, the outer and inner, the negative 15x and the negative 14x. This would be what, a 10x squared? Is that a minus 29x and plus 21? Notice that the middle term we got by combining the outer and inner. Let's do another one. And if you're thinking, well, wait, you'll see why I'm mentioning this in a moment. So as we had 4x minus 3 times 5x plus 2. First, outer, inner, last. What would we have? 20x squared. And here come the outer and inner. Those are the ones that are going to be like terms. A plus 8x and a minus 15x. And last, minus 6. So if we combine this outer and inner, we have 8x minus 15x. What are we going to wind up with? So we have 20x squared. Y'all hear 7? It's going to be a minus 7x. Is that right? Minus 6. So once again, to get this middle term, you're combining the outer and inner terms. In algebra, I'll say this over and over this semester. You always do stuff one way, then you do it in reverse. We were foiling here. What we're going to be doing today, factoring, that's when you're going in reverse. Given this, come up with these two sets of parentheses. Given this final answer here, it's called a trinomial, 3 terms, come up with these two binomials here. Okay? So we're going to be going in sort of reverse FOIL. And if you look at this, if we imagine going backwards, we were trying to fill these numbers in here. Well, up here, you had a negative and a negative. When you combine two negatives, you're adding. You're adding the 15 and 14. Right here, the 8 and 15, we're not adding them. What are we doing? Subtracting them. I'm just going to go ahead and write this table that my brother mentioned that I write. I spent many, many years teaching a whole lot of Math 371. It used to be called elementary algebra. I think it's called, what, developmental math now? Okay. So I'm going to make a table. Oops, I think I wrote second form. Why did I write the second sign? Oh, my beautiful table's already messed up.
I think you should start it on another page, at the top of the page.
Okay, good thing.
Okay. I should say second sign.
Yeah, you're supposed to say second sign. What this table's going to do is tell you how to figure out what signs you have in the parentheses. Again, we're going backwards. Given this, come up with this stuff right here. It all has to do with this second sign right here. I'm calling this the first sign, second sign. Down here on this one, this would be the first sign, the second sign. I'm going to assume this first number is always positive. And if you're wondering, well, wait a minute, if it isn't, then that's the third sign. Don't get into that. I'll justify why later on. We can always make the assumption this first sign is positive. So, if the second sign is plus, your factored form has 2 of the first sign. Why is that? Why am I saying? Well, if we needed numbers that multiply together to give a positive 21, what type of numbers multiply together to give a positive? Either 2 positives or 2 negatives. How do we decide which one it is? By looking at this first sign. Notice, both of these numbers here were negative. That's why this sign here is negative. So you look at the second sign, it's a plus, so right off you know that the factored form has 2 of the first sign. I don't like that blank. I will fill those signs in immediately. Why? Well, I know that the first sign, the factored form has 2 of the first sign. So minus minus from there. Now, what about if the second sign is negative? Before you ever came in here today, you could have answered this question. What type of numbers multiply together to give a negative number? Would it be positive times positive, negative times negative, or 1 plus and 1 minus? A positive and a negative. If the second sign is negative or minus, there's 1 plus
inside the parentheses
and 1 minus. Let's look at this one over here. My second sign was minus, and am I right? Is there a plus and a minus in here? There is. But you don't know immediately where to put the plus and where to put the minus. If you have 1 of each, maybe the plus should go in the first set, or maybe it goes in the second. So when I'm doing this, if the second sign is minus, I'll wait to fill those in. Whereas if the second sign was plus, I'll fill it in immediately. It's 2 of the first sign. Now, to get the middle term from the outer and the inner. How do we get the middle term from the outer and the inner terms? Well, over here on this one, if the second sign is plus, what did we do to the 15 and 14? Did we add them or subtract them to get a 29? You add them. If that second sign had been minus 8 and 15, we don't add them together. What do? Subtract. Now, once you're really good at factoring, or if you're already good at factoring, then the table will make sense. Unfortunately, sometimes you get stuff in class, and it doesn't really make sense until you get, oh, now I see what the heck he's saying. Let's just try to, this is called factoring. Here's an example we'll do before we actually do one of the homework problems. Factor x squared minus 5x plus 6. By that I mean, oops, this minus right here, I'm going to put that as a plus. There. X squared plus 5x plus 6. What it means when it says factor is you need to write out the two sets of parentheses and fill it in. Fill it in so you have something you can FOIL out and get x squared plus 5x plus 6.
Formally, factor means write as a product. So when you're factoring, let's say the number 10 and number 10, using prime factors, it'd be what? 2 times 5. So factor means write as a product, and that's what he's doing right here.
Okay, can y'all use the table and tell me what signs am I going to put in here? What's my second sign? Okay, so the second sign is plus. What am I going to have in my parentheses for the factored form? Both positive, two of the plus and plus. I can fill that in right now. I know they're both pluses. Now, imagine foiling in your head. What would have to go here and here when I do first to give me x squared? X and x. Okay. Now the last two positions, here and here, those should multiply together to give me a 6. So my brain, I'm thinking, what numbers multiply together to give a 6? Well, there's 1 times 6 and what else? 2 times 3. And y'all tell me which pair of these numbers, how will I decide which one works? Because only one of these pairs will be right. Well, you're looking at that middle term. You want these outer and inner numbers to add together to give you this. Which pair do y'all think is going to work? 2 and 3.
A trinomial where the leading coefficient is a 1. You just have the variable square. You don't have a number in front of it. That's called a simple trinomial because it is simple to get it factored. There's only one possibility for first times first, the variable times itself. Simple trinomials, they're simple to factor.
So let's FOIL this out in our head and make sure this is right. If I do the first, x times x, is that giving me x squared? Yeah. Now, do the outer and inner combine together to give me 5x? Let's see. Look at the marks I'm going to make for outer and inner. This is just my way of saying, okay, that's outer. X times 3, that would be 3x. Inner, or the inner 2x. The 2x, a positive 2x and a positive 3x, do those combine to give me a positive 5x? Yeah. And then last, well, positive 2 times positive 3, is that positive 6? Yeah. This is sort of a trial and error, but we sort of give you hints on, so it's not, you're not just sitting there randomly choosing numbers. Like in the last two numbers, you would never put something like 5 and 3 because you need numbers that multiply together to give 6. Okay? What about this one? It's going to look very similar. X squared plus 5x minus 6. If you're thinking, wait, it's the same problem. No, it isn't. What did I do? I changed that second sign. That changes the problem completely. Instead of the plus 6, we have a minus 6 as our second sign. Can you all look at that table? and tell me, or just think it through like my brother says. Just think it through. What numbers multiply together to give a negative? One positive, one negative. I'm not sure where the plus goes and where the minus goes, so I'm going to wait to fill those in. I'm just going to make a little note. I'm going to put a plus minus right there, so I'll remember there's one plus, one minus. The first positions, x and x. The last position should multiply together to give 6. So 1 times 6, 2 times 3. The 2 and 3 worked the first time because they added together to give that middle term. What about this time? It's going to be the 1 and 6. 1 and 6. Now, here's where you got to sort of think. How do you arrange the plus and minus? Where do I put the plus here, or do I put the plus here? If you get it wrong, just reverse it. So, where do y'all think the plus should go? In front of the 6. If we make the 6 positive and the 1 negative, let me see. Is this right? I'm going to make these little marks here just to see. Is that going to give me a positive 5x? I know the first times first is x squared. I know negative 1 times 6 is negative 6. But if I look at these, am I getting a positive 5? I'd have a negative 1x and a plus 6x. Is that giving me a positive 5x? Yeah. But I did these two examples to sort of illustrate what I mean by this table. Okay? You can imagine if there's a lot of numbers or if there's big numbers.
Suppose that were 24x squared. Well, you know you need x and x, but what would give you 24? 1 times 24. So
2 times
2
12.
times 12.
3 times 8. 4 times 6.
Which one do you use?
Well,
Not always easy to figure out. But
here's a hint when you're going through these. There should be no common factor. Other than 1 in the parentheses. If you're factoring these correctly, what the heck am I trying to say? When you're going through trying this trial and error, that's all it is. Figuring out how do I get that middle term. If you had something like this, 10x minus 12, could that ever be part of your answer? Well, is there some number other than 1 that divides into both of these? 2?
Can't be right.
Can't be. You don't even need to check it. In fact, what about any 2 even numbers? Could you have 2 even numbers in the parentheses? No, because they'd be divisible by 2. What about this? 15x plus 24. Could you ever have that? Is there some number other than 1 that divides into both of these?
3.
3.
Can't be right.
Can't have it. What about something like this? 15x minus 16. Could you have that when you're factoring? That's a 16.
Mm-hmm.
Is there any number other than 1 that divides? Nothing?
Into
Both of those? When I say divide, I mean with no remainder. The only number that divides evenly into both of these is 1. That would be okay. Now, before y'all start panicking and before we get logged out, click on problem 2, Tim.
Or have we already?
Here I'm just going to go through some particular problems. This is one of the assignments where I don't just go through everything. It says factor this trinomial, and then it's telling you, notice that the coefficient of x squared is not equal to 1. So that means it's not going to be quite as simple as the first 2 we did that I made up.
A prime number is a number that can't be factored, that can't be written as a product about anything other than 1 in itself. For example, 5. It can only be written as 1 times 5. 5 is prime. A trinomial that can't be factored as anything other than 1 times itself is said to be prime. So if it's impossible to factor, you would select the B option, that it's prime.
And we'll see one of those in a little bit.
Have you written it down?
15x squared minus 11x minus 12. Well, y'all know one thing. What sort of signs are we going to have in the parentheses? Second sign is minus, so you said a positive and a negative, a plus and a minus. So I'm going to draw.
Second sign is a minus, so a plus and a minus.
Yeah, that was on the table.
Why were you pointing at the first sign?
I pointed at the first sign. I meant to point here. The second
I think
sign
you were
is
pointing
minus.
at the first sign.
So,
So you're going to have one of each. One
so I'm just going to
plus.
make a little note, plus and minus. Do y'all see why this one's a little bit harder than the other one? I'm not just going to put x and x here. I need these first two numbers to multiply together to give 15. So let me think of all the numbers that multiply together to give 15.
1x times 15x.
And there's another set, 3 and 5. Now, when I say numbers today, I'm not talking about fractions or anything. If you're thinking, well, what about a half times 30? Okay, well, no. I just mean counting numbers. What numbers multiply together to give 12? 1 and 12, 2 and 6, 3 and 4. Well, here it's trial and error at this point. You got to figure out the correct pair that'll make it work out and give us a negative 11x in the middle. Well, let's start off with the 15x squared. Do I want to use 1x times 15x or 3x times 5x?
Do you want to try?
Do I want to try?
You're just trying it. The one he chooses may be wrong. We may have to change. But which one do you want to try?
3 and 5. Generally, I try the two numbers that are closest together on the number line first.
Unless I have reason not to. And we'll discuss.
If this number here in the middle is a real large number,
then I might try. If that number is a real big number, I'll probably try 1 and the number, because if you're using a 15's that time something is going to give you a bigger number. So that's one of the things. If this number is if that had been a minus 110x, I'd probably start off with 1 times 15.
And you know what? Right over here, suppose I said you can't have two even numbers in the parentheses. What about the same number? Could I have a 3x plus 3 in parentheses? What number other than 1 divides into both of these?
It should be obvious.
3. Can you have the same number in the parentheses twice? No. Okay? So having said that, I'm going to try out the 3-5 paired with the 3-4. If I'm going to try that first, where should the 3 go? Right here with the 3x or over here with the 5? Yeah, it can't be with the 3. Remember the time, twice in my life, I've had hostile students that said, once in trigonometry, we were doing some proofs, and then once when I was teaching this, I don't have hostile students anymore, but then I had a hostile student, and he said, you're just making this work out. And the rest of the class sort of laughed. He was so mad. And I thought, let me diffuse this. That is brilliant. I'm going to remember this. I realized this was 1992 when the student told me this. Okay? I said, that is brilliant. I'm going to remember you. You're going to make it work out.
That's what you have. That's what you're doing. You're making it work out. You're choosing numbers so that the outer and inner you'll make it equal a negative 11x.
And you're only using numbers that'll make the first one give you 15 and the last give 12. So that student, yes, you're making it work out. Let's look at my outer and inner. I'm going to make these little marks. We have a 9x.
What's the inner? right there.
20x. Now keep in mind, there should be a plus and a minus.
Go back to that table. When you have that last sign of minus, I'm getting the hang of this table at Tony's. That last sign of minus, you're subtracting the outer and inner. Can you subtract the outer and inner in a way to get that 11 that you need? Yes.
Yeah. Okay, so follow my signs. I want an 11x. So since this is negative 11, the bigger number should have the negative, right? Isn't that how we add positive and negatives? When you add a positive and negative, you keep the sign of the number, the bigger number. So the 20 should be negative, which means what? In front of the 4, a plus or a minus. Minus and a plus there. Then if you want to FOIL it out to check it, great. It takes a lot of thought. Okay? But as that student said way back, before most of y'all were born, you're making it work out. I wonder if it ever happened to them. Let's try another one. Are we ready to try another one? It takes a lot of thought. But you know. And if you took developmental math, or if you just took algebra recently in some other school or something.
Wait a minute, I didn't type in the answer.
Oh, yeah, I forgot about that.
For parentheses, sometimes they'll have, like here, they have a parenthesis there on the hot button. That's really for an ordered pair. You see that comma? I don't use that. To type a parenthesis, I just type a parenthesis from the keyboard. 3x minus 4. Right parenthesis, then a left parenthesis, 5x plus 3. And I should mention, as long as you have the same thing inside the parentheses, the order doesn't matter. If I typed 5x plus 3 in the first set and 3x minus 4 in the second, I would still have the correct answer. Any questions there?
Go to number 4. Oh, wow. Okay, so y'all see what I mean about the 56a squared. Number 3 is real small numbers.
I know.
Plus 121a. Ugh.
There's one thing I like here. There's one thing I like.
When you think, oh, this
When I write my parentheses, I know what signs to put in there. I don't have to wonder, I better wait. So what do I know about the signs inside these parentheses? Okay, the second sign's a plus, so you have 2 of the first sign. So you don't have to mess with any negatives or minuses. It's plus, plus.
Now here's where we start thinking. Numbers that multiply together to give 56.
See, you just write the number part. You know what I do, Tony? For like 56a squared, I go, it could be 1a times 56a, or 2a times... Wait, let me switch. I'm not saying this is better than what you're doing, because you know that for the a squared, you know you're going to have an a and an a, right?
That's why I don't write it.
And so, and
so
I
numbers that
28a, so...
1 times 56, 2 times 28. 3 doesn't divide. What about 4 times 14?
Mm-hmm.
4 times 14, 56.
56.
And one more pair, 7 and 8. Okay. Now, I'll do the same thing with 63. A lot of numbers multiply together to give 63. 1 times 63. 2 doesn't divide into it. What about 3? 3 times 21. 7 and 9, is that it? Maybe there aren't that many. Can you think of another pair of numbers that multiply together to give 63?
I think that's it.
So, I'll generally try the numbers that are closer together on the number line. The 7 and 8 for 56, and I'll try the 7 and 9 for 63. Notice I'm saying I'll try. I hope it works. 7a 8A. I'm going to try pairing it with the 7 and 9. If that doesn't work, I'll try the 3 and 21 and so forth. But if I'm going to try it with the 7 and 9, how do I need to arrange it? Can I put the 7 here? No, can't have the same number. And 9 and 7. Now, how do I decide if this is the right answer or not? Are we going to get the 121? You look at the inner and the outer. Oh, is this going to do it or not? That is 72A, and what's this other one?
I think you're just getting lucky again.
49A? Do those combine to give a positive 121A? Yeah, I think it did. Okay.
We're just getting lucky here, beginner's luck. There'll be some where that 7 and 9 doesn't work. So we'll wind up trying the 3 and the 21. And it won't work. Maybe we'll have to go back to the 1 times 63. But here for these first few, any questions there?
Well, type it in so I know it's right.
I don't know why I keep forgetting that. So parentheses 7A plus 9 and a 8A plus 7.
Again, he could have written 8A plus 7, parentheses 7A.
Hey, let's do that. Notice how Tony...
Just because how I have it written, the order doesn't matter. If you write the 8A... Okay. There's two answers. You could write it like that, or like this: 8A plus 7 times 7A plus 9.
You have to have the same thing inside the parentheses, but you don't have to. But it can be in either order. So I'm going to type the 8A plus 7 times the 7A plus 9, just to point out that the order that he's writing them the first time doesn't matter. So
8A plus 7. 7A plus 9.
Any questions there?
How about 5? This is going to do that.
Oh, there's something wrong here that I don't like. I like the fact that the numbers are a lot smaller than in the previous problem, but there's something I don't like.
Is that a B?
V like Victor.
3B squared minus 3 minus 8B. 3B squared minus 3 minus 8B. In order to do factoring like this, we got to sort of have it in a certain form. If you look at the first problems we've done, it's always like x squared x constant. A constant is what you call a number that doesn't have a variable. X squared x constant. A squared a constant. X squared x constant. X squared x constant.
And when you're falling stuff out, that's how it falls out.
Yeah.
So when you're falling out, you get the variable squared variable and then the constant. So what do y'all think we're going to have to do to number 5? Before we start writing our parentheses and our factors, what do you think we need to do?
There should be a b squared. What should the next term be? Okay, so just rewrite it like this. 3b squared minus 8b and then the minus 3.
And now I like the looks of this, okay? Because for 3, if you're using positive integers, there's only one pair that'll give you a 3. What times what equals 3? 1 times 3, okay. Oh, what do we know about the signs? Okay, the last sign's a minus, so you have 1 plus and 1 minus.
So I'll try b times 3b in the first position. Having done that, there's only one other way we can arrange.
What's going to go here? The 3 will go there, and here, the 1.
The reason, my mind went blank. The reason you don't have the 3 over here is because you would have a common factor. And so right here, if you think of that as 1, V, and 3, the only common factor is 1. Here, the only common factor is still a 1. How am I going to arrange the plus and minus in order to make it work out and give me a negative 8V? What were you going to say, Tim?
I was going to ask, what are we trying to get? We're trying to get a negative 8V. You said it.
Okay. The bigger number should have the negative. So 9 is the thing that should be negative. So put a minus in front of the 3 and a plus in front of the 1. I started to mention this earlier and I got sidetracked. If you've done this recently, say you took developmental math last summer, then all of this is going to be, right fresh in your mind. If it's been a while, then that just means you got to work a little harder. Okay? A lot of times students, should I drop the class? I didn't. No, my answer is always no, don't drop the class. You just work harder. There's more, how you do in a class generally has more to do with what you're doing right now than what you've done in previous semesters. Is that right, Tim?
That's right. Let's see. There's something called the AC method of factoring. Okay, the AC method. And if you took Math 371 recently, maybe your teacher taught that method. Well, the problem with that method is you can never really gain speed. Whether it's a fast one like this or something like this, it still takes the same
People
amount
say
of
the
time.
AC method is faster and or easier. So the teachers that teach that, I will never teach that. Because if, like on number 4, if you've ever done this, where the first thing you do is multiply 56 times 63.
And then you got to get all the factors of that big number.
If you've ever done that and you remember how to do that AC method, great. I will never do that method in class. If you go to another math class after this, the teacher will never be doing that AC method. Okay?
I remember speaking to a colleague that's retired that used to teach the AC method, and he said, that's what he used for his algebra classes, is 371 and 373. Back then there were 2 developmental courses. And then I asked, well, okay, you're having to factor something in your trig class that has 3 terms. So how do you modify the AC
Oh no, I
method?
use trial and error then.
Wait a minute. So your method doesn't work when factoring trigonometric expressions. I thought that was a big problem there, okay?
Our little trial and error method. Well, anyway, enough of that.
Okay.
Let's go on to problem 6. Oh, wait, did you punch it in to make sure it's right?
No. Okay. So it is left parenthesis V minus 3. And by the way, if you put X minus 3, they're going to count it wrong, okay? So be careful. Be sure to use
the variable that
they have in the problem. Any questions there?
You'll notice that option B that keeps popping up. It'll say either the trinomial is not factorable. Imagine if instead of 8 right here, instead of 8, suppose the number was 3v squared minus 1,000,000 v minus 3. Is there any way you're going to get 1,000,000 from the outer and inner? Of course not. So it's not always possible to factor these things. Let's look at number 6. 6x squared minus 13x plus 11.
I like the signs. Oh, well, we're going to have to rearrange the terms like we did on number 5. No, they're already in the desired order. We have the square variable, the unsquared variable, and the constant. So we're not going to have to change those.
And you know what? Let's call that x squared x constant standard form.
Or descending form.
Okay.
Mm-hmm.
With the exponents.
But most books call it standard form, but I like to call it descending form or descending order because the exponents are getting smaller. You have an exponent of 2, an exponent of 1, and then no exponent. So let's go to the paper. Let's push the paper back.
I need every bit of this room. Okay.
Well, I like the signs. What do I know about the signs? I can fill them in right now. They're both negative.
The second sign is a plus, so 2 of the first signs. Okay, let me think of numbers that multiply together to give 6. There's 1 times 6, 2 times 3. Oh, fortunately, there's only one pair that multiply together to give 11. 1 times 11. Oh,
we can fill in the 1 and the 11, I guess.
Yeah. Now let's try. I'll try what? There's no common factor other than 1, unfortunately. So that doesn't knock out anything. I'll try 2x and 3x. Foil that out, and are we going to get a negative 13x? We'll get the 6x squared and the positive 11. But in your head, are we going to get a negative 13x? We'd have a negative 3x, and what about right here? Negative 22x, is that going to give me a negative 13x? No? I'll mark that one out. So we've tried one of them, it doesn't work.
Reverse the 2x and the 3x.
Okay, let me try that.
Maybe it should be 3x minus 1 and 2x minus 11. Y'all see what he's doing? Y'all see why this method, this reverse FOIL, is frequently called trial and error? We tried something. It didn't give us the outer and inner, didn't give us the middle. So now we're trying something else. The 1 times 11, it's not like we have another option for 11. But for that 6x squared, we tried 2x and 3x. Now we tried 3x and 2x.
Are we going to be able? We got a 6x squared from the first terms. We've got a positive 11 from the last. To the outer and inner, are they going to give a negative 13x?
Looks like a negative 2x minus a 33x, right? I think we're even worse off than we were a moment ago.
So let's think. So we've used
33, not 3.
Oh, yeah, 33. But significant thing is we're not going to get a negative 13x out of that.
I think we can scratch out the 2 and 3 option.
There's still,
so if it's going to be factorable, we're going to have to use 1x times 6x.
Let's try that. 1x times 6x. They're both minuses. I'll try 1 and 11. And if you think, well, wait, there's a common factor right here. Yeah, but it's 1.
You can have a common factor of 1.
You can't have.
You will have a common factor
Yeah.
of 1. But that's the only common factor you can have.
Is this going to give me a negative 13x? I don't think so. We'd have a negative 6x and a negative 11x.
I think that's what is that going to be, a negative 17?
Yeah, that doesn't do it. There's only one other possibility for us to check. And if this doesn't work out, then we'll have to click, what did it say, not factorable or prime, whatever. So what's that other possibility? Let's try, okay, the 1 and 11.
The 1x and the 6x.
So put a 6x here and
I
an
can already
x
tell
there.
that's going to be even worse.
Is that going to give me a negative 13x?
That's 6x times that negative 11, that's a negative 66. We're getting much further away from negative 13x.
So all of that.
And can this thing be factored? No. We come back over here.
I like it to say not factorable, but sometimes it'll say prime. It means the same thing.
There it said prime. Click.
Okay, prime. Okay, so if you're one of those people that today you're going to go home and do your homework when you're through, just remember number 6 is prime.
But that doesn't help you on a test, okay?
Well,
you still need to try this. But it is true. Everyone's number 6 in the homework is going to be prime.
Mm-hmm.
I guess I should set it so that everything goes in a different order. Now, the test questions
will be in a
randomly arranged, but
the homework, no, I think the homework is in a particular order for a particular reason. Okay?
You may not see the reason.
But up here, I know
we have a reason for how we arrange these problems.
Mm-hmm.
Number 8. Oh, I like the looks of this.
Oh, yeah. Number 8. We're just doing the even number problems as examples. 2. Is that a W squared? In case you wonder, why does he wear glasses and then not wear glasses and stuff? Something weird is going on with my vision. The last time I went to the doctor, I told him I can see better without my glasses. I only need my glasses if I'm reading small print on my phone. And afterwards, the doctor said, well, you're right. You don't need your glasses anymore for anything except reading small print. And so, if you're sitting there thinking, oh, well, he needs to wear his glasses. No. I can read that screen over there just perfect. If I put on my glasses, it's blurry as heck. So, they tell me to go get reading glasses, but why would I do that? I have Gucci glasses right here I paid a fortune for, so I may as well wear those, right? Go to the dollar store. He told me, go to the dollar store and buy some reading glasses. I was like, I'm not going to do that. Huh? Have I talked enough? Could y'all talk me through? Or have y'all done it?
Yeah. Did y'all do it? Yes.
What sort of signs? Oh, Tim, they can't see my writing.
They can't see it. Okay.
2 pluses, 2 minuses, or 1 of each? One of each. Second sign is minus. Okay, so 1 and 2, 1 and 2. Just remember, you can't have the 2's together in the same set of parentheses. If this is going to work out, I'll say 1W times 2W, and I'll put the 2 and the 1 here.
We need a negative 3W. The outer and inner need to give us a negative 3W.
So 4W, 1W. I want a negative 3W, so that means...
Which one of these needs to be negative to get a negative 3W? The 4W or the 1W?
The 4.
The 4?
The bigger.
So which one needs to... Where do you put the negative? In front of the 2 or in front of the 1? In front of the 2, okay.
Oh, this is such good thinking here. You are right about just having to think about it. Okay?
I think you're making fun of me.
No, I'm not.
Oh, goodness. Well, if you think about it, you have to think about everything, right? Y'all think that's right? Want me to type it in? Now, once again, the order... My own personal math prejudice is I put the small and then the big coefficient, like 1 times 2. And I see Tony does the same thing, 1 times 2. When we go back, he's consistently 7. 7 times 8. You see, go small to big.
3, 5.
But if you're one of the people that puts the big coefficient first, here you'd have a 2W plus 1 times a W minus 2. That is perfectly fine. As long as you have the same thing inside the parentheses, the order of the parentheses doesn't matter. Now, if you write a W plus 2 and a 2W minus 1, that's wrong. You have to have the same stuff inside the parentheses, but the order of the parentheses themselves don't matter. So I'm going to put the 2W plus 1 first, just to show you. I want to remind you that, and what was the other one, a W minus 2? Any questions there?
Well, no. Okay. Show my screen. I want to define something. In your this is not an entry-level algebra class. None of you are in here having never taken any sort of algebra ever before, okay? One of the first things you do in algebra is solve linear equations. And linear equations have no exponents in them, and an equation must have an equal sign. I'm going to define what's called a quadratic equation. A quadratic equation can be written in the form ax squared plus bx plus c equals 0. Up until the next problem we do, number 10, those have not been equations. We'll come back to the screen, but look, are there any equal signs there on number 8? Maybe you put equal signs when you were working it or when you put the answer, but in the original statement of the problem, there's no equal sign. It's sort of important.
Something else. No.
Yeah, it doesn't say like equals 0 there on that problem number 8. It's sort of important to be able to distinguish how does this problem work. Number 10 is going to be different from number 8. How do you tell the difference? It's sort of important to be able to do that in algebra. How is this problem different? With a quadratic equation, there has to be an equal sign, and there has to be an x squared.
Maybe we should say a cannot equal 0.
Oh, Tim, I was going to ask them to tell me, if we make this a formal definition, what's the one number a can't be? If I'm saying there has to be an x squared, well, a can't be 0. There's the formal definition of a quadratic equation. Now, I've already used...
Now, to favor 0, 0 times x squared, you don't have an x squared term. You must have an x squared term in order for the equation to be quadratic.
Now, there's another type of equation that you've seen in a previous algebra class where there wasn't an x squared, and I used the word already once today, a little while ago. It starts with an L. Do y'all remember what you call an equation that doesn't have any exponents? Linear. We have linear equations. That would be bx plus c equals 0. And then we have quadratic. If there's an x squared in the equation, then that's called a quadratic equation. And why don't you go ahead and show number 10, but I'm going to write out how we're going to go about solving it first, but my steps might make more sense if you see the problem. How does number 10 differ from number 8? It says solve the equation for A.
It doesn't say factor.
Factor. Okay.
Number 8, all it says is factor.
Factor.
And notice it isn't equal to a number. The problem doesn't have equals a number. Number 10, if it's an equation you're solving, it must have equal a number. Well, it may not be 0. It may be something other than 0, but you'll have to get it equal to 0 before you can solve it.
We're going to see today, and especially on Monday, different ways of solving these quadratic equations. The first method we'll see is also, by the way, the last chapters of developmental math. If you took Math 371 recently, that's where 371 ends, is solving quadratic equations by factoring. So how do we solve a quadratic equation by factoring? It's a 3-step process. Step 1 might already be done for you. write the equation in standard form.
That means descending order on one side based on the exponents. X squared, X, and no X. You must have 0 on the other side.
Okay. Now the second step is the one that's only one word, but it's actually the long part of the problem. Once you get it written in that standard form, you factor it, just like we did number 8. You factor it, okay? Notice it's in standard form. Factor.
There's something called the zero multiplication property. The only way a product can equal 0 is for one or more of the factors to be 0. Something times something equals 0. Well, that's what you're going to do when you factored it. You're going to have something times something equals 0. The only way that can happen is for one or more of the factors to be 0. So set each factor equal to 0 and solve.
So we're going to go from a quadratic equation to 2 little linear equations. And we'll be solving linear equations. It sounds worse than it is.
Once you get the factoring done, the rest of it is easy. Okay, so.
So there, I'm going to put it like that. I don't know what's happened to these pages, the way they're flapping up.
We have to
buy a new notebook. Yeah. Okay. So let's do number 10 now. What was that problem?
5a squared plus 27a plus 28 equals 0. I said sometimes you have to move terms around to get it into standard form. Do I have to move anything around here? It's already in standard form. Notice the descending order, the a squared, a, no a, and you have a 0 on the other side. You've got to have a 0 on the other side. And so yes, this is in standard form. Let me switch over to the paper. We've convinced ourselves that the equation's already in standard form. So we've done step 1. Only 2 more steps to this problem.
That's factor. Well, I think of numbers that multiply together to get 5. Ooh, 28. There's 1 times 28.
2 times 14. What else? There's 4 times 7. Right. And that's it. No 5, 6.
So I'm going to draw my 2 sets of parentheses. Okay. Well,
for 5a squared, there's only one possibility.
Well, I was going to ask about the signs first.
Oh, yeah, we know the signs.
What sort of signs will we have in here? The second sign is plus, so 2 of the first, so plus and plus. Are y'all caught up with me? Those of you way over there.
The peanut gallery, y'all caught up? Yes?
Yeah. Okay. So, I'll say 1a times 5a. Now it's
what do y'all want to try for 28?
Okay.
4 and 7. If you don't really have an idea, choose the closer pair. You know, try that.
4.
Try 4 and 7.
And 7.
And I think we're just getting lucky here, okay?
Well, if I'd put 7 and 4, I would have had to switch. I think this is it. Can y'all do that outer and inner in your head? We'd have a 20A and a 7A.
Is that what we needed? 27A? Yes. So we factored it correctly. Now, the only way a product can equal 0 is for one or more of the factors to be 0. So set a plus 4 equal to 0. Set 5a plus 7 equal to 0.
And what we're about to do is called solving a linear equation. It's called linear because there's no exponent on either of these red equations. To solve a linear equation, you do the opposite operation to both sides of the equation, beginning with addition and subtraction. The opposite of adding 4 is what? Subtracting 4. Remember doing this stuff like that?
We need to get the variable by itself. We want variable equals a number. That's what we're trying to get. And I think that's what we have now. What have we got on the right-hand side? 0 minus 4 is negative 4.
So there's our first answer. By first, I just mean it's the first one we found. There's not any real order here. You don't have to do one number before the other. Now right here, this is going to be a good example of solving a linear equation. Isolate the A by doing the opposite operation to both sides of the equation. The opposite of adding 7 is subtracting 7. So we have 5A equals negative 7. And now, this 5A, that means 5 times A.
What's the opposite operation of multiplication? Division, so you divide both sides.
I'm thinking we're going to have a fraction here as our answer. We have two answers, negative 4 and negative 7 over 5. Negative 4 and negative 7 over 5. This isolating the variable by performing the opposite operation to both sides of the equation, beginning with addition or subtraction. Notice, is it clear what I mean by opposite, beginning with addition and subtraction? I subtracted the 7 before I divided by 5. Okay?
There's also something called transposing terms. Rather than the opposite operation thing, you could just pick up the 4, you move it to the other side, and when you move it to the other side, you had a positive 4. When you moved it over, what happened? It became a negative 4. So you may have seen your teacher in previous classes
instead of this stuff here, they might have done this, just a little arrow, which means move it over and change the sign.
Move the 7 over, change the sign, that becomes a negative 7. Divide by 5. Realize you don't change the sign when you're dividing. Okay? If we're going to use that transposing terms method, you change the sign when you're undoing addition or subtraction. You're moving the stuff, but when you're dividing, you don't divide by negative 5. You divide by 5 itself.
On the first quiz, there'll be a good number of problems that are just factor completely, like this. I remember one semester, I don't know what, a whole group of students, it was so weird, everything that said factor completely, they went ahead and stuck a 0.
W equals 2, W equals negative 1/2. Well, they type in 2 comma negative 1/2. We did something wrong that semester.
Yeah.
I don't know what, but
they were all telling us they've done, that's why I'm making sure I'm hitting the instructions. Years ago, like in 1991 or so, we were at Bamboo Garden, the waiter came up and, y'all teach math at Delmar? Oh, yes, we do. And, I'm taking math at Delmar. Oh, okay, well, what do you do? How's it going? Well, it's okay. Except my teacher's an idiot. Oh, I immediately try to disengage. And and he said,
he tells me to study the instructions.
He's always talking about reading the instructions. No, I said, wait,
that's sort of
important. And I could tell. He closed his mind and walked away from us. It's some of those idiots again. Those idiots telling him read
instructions.
Who'd ever heard of that? And I don't know whatever happened to him. But it is sort of important to read those instructions.
Whether you're factoring or solving, that's important. And if you don't think so, then when you take the test, you'll see. Now, if it's an equation, notice, if you're solving for the variable, they're not just going to have a blank there for you to type in the parentheses. They actually, my math lab has the little variable equals. It says use a comma to separate answers as needed. So I'm going to type the integer answer in first, which was negative 4, comma, and then What was it?
Negative 7 over 5.
Negative 7 over 5. If it's just a number over number, I'll be lazy. I won't use that fraction bar. I just use the little slash from my keyboard. And then as soon as I hit that little slash, it switched it into a fraction for me. Any questions there?
So let's do 12.
12, okay.
Oh, is that a 12R?
Plus R squared plus 32 equals 0.
Mm-hmm. 12R plus R squared plus 32 equals 0. Well, it has an equals 0, so that's good.
Yeah.
But
So
is it in the standard form?
Is it in the form we need it? The equals 0 is the form we need, but what about the left side? You tell me what we have to do.
Mm-hmm.
Okay, so we need that R squared first, and then we have the R term, the plus 12R. And why is it a plus? Because that 12 right there is assumed to be positive. You don't see a sign, so it's a plus 12R.
And now that since we mentioned transposing, moving it and changing the sign right here, that's if you're moving it across the equal sign. Notice, the R squared and the 12R, we didn't move those across the equal sign. That's why it didn't become a negative 12 or anything. They're both on the left side of the equal sign, so we're just keeping the sign that's with them. The R squared is positive, the 12 is positive.
Oh, it's a simple trinomial.
Oh, wow, it seems like a long time since we had one like
I think
that.
it's only the second one. I think it's the only one simple trinomial we've had in the homework.
Yeah, well, when I was we were looking through choosing which problems to do, I want to do the harder ones generally.
Okay. Write your two sets of parentheses. We know something nice about the signs inside those parentheses. I couldn't hear you. Okay.
Positive.
Second sign's a plus. Two of the first sign. Plus and plus.
And also, I'm going to go ahead and put an R here and here because we know that's it. But what about numbers that multiply together to give 32?
I'll get it started. 1 times 32.
And how about
2 times 16. 3 does it. 4 times. I think it's just 4 times 8.
Okay. 4 times 8.
4 times 8.
Do y'all have an idea of which?
Evenly. 6, 7, 8. Oh, we're back to 8. So that's all there is. You see what I'm doing is I go through thinking up those pairs. I start at 1. 1, 2. Does 3 go evenly? No. 4, 5, 6. 4 does go evenly. 5, 6, 7, 8 goes in evenly. I've already got 8. I know I've got them all then by going like that. So which one do y'all want to choose? A simple trinomial, it's simple to choose the pair you want to use. 4 and 8.
Wow, why can't they all be this easy?
The funny thing is, as we get into some of the messier equations with radicals that we're going to be solving, a lot of those messy equations ultimately reduce to a simple trinomial. So simple trinomial, factoring those efficiently is important because they do pop up quite a bit. It's not something that's so easy that we'll never see again.
Am I finished? No, I still got to go that third step. Set each factor equal to 0 and solve. By solve, I mean isolate the variable. So I'll write R plus 4 equals 0. And R plus 8 equals 0.
Getting R by itself on the first one, what are we going to have to do?
Subtract. I'm going to do just my little arrow. Move the 4 across and change the sign. So negative 4 and negative 8. A lot of times students say, oh, wait, I can do that without all those steps. You don't have to show every step I do. Your goal is to get the right answer quickly without using photo math or artificial intelligence. That's AI, by the way. Y'all, they did it to the choke.
I know.
I get that choke. Okay, it went right over them. Okay. My goal is to try to show my thought process. So -4 and -8. Do y'all see how the difference in the answers if it says factor versus solve? If it says solve, your answers are going to be numbers. They might be fractions.
If it says solve, notice it's giving the little variable equals. They're telling you need the variable by itself. Whereas if you go back, let's look at number 8. When you're factoring, they're not saying variable equals. You're just writing it. It just says equals, and you write in the factorization. What number were we doing? 12? Okay. Okay, so we have
-4.
-4 and -8. Now, it doesn't matter. You could have written -8, -4, as long as you have the correct numbers themselves. Now, when we get to interval notation, we'll have to be writing small number to big number, okay? So order will matter. But here, let's type the two numbers in whatever order you want to. Any questions there?
It's going so well. It's only 3:21. Let's do. I was going to do 15, but let's do 15. Then we'll go back and do some more to kill some time. I'm sounding like him. First time we ever talked together.
My first day back, I'd finally finished the radiation. I was back here after 2 months up in San Antonio being radiated, and it was exciting. Tony had been teaching both of our classes, you know, opening the wall. Like first semester the building opened, it was just like, you know, fated, decided, oh, you got this room with that wall that can be open. Let's make one of them be sick so that he misses several months of class. And so I'm back on the first day, and things are going great. I'm having a great time.
We finished everything.
It's right there the day before spring break. It's the last meeting before spring break. Little did we know it'd be another 2 years. I wouldn't be back in the classroom for 2 years after that, but still.
Tim said,
Tony
wait, we still have so much time.
We still have 40 minutes, Tony.
Yeah,
Let's do some more problems. Everyone was closing up their books, and they laughed and kept on, and I started working the problem, and it dawned on them. He ain't joking. Oh, and they opened their books, and at that point, I knew the class did not like me. It was fun and games. We had a great time until then I was like, okay, I should have kept my mouth shut. I should have said, okay, we're through. Let's go.
Is this
in standard form?
No.
No.
We need a 0 on one side.
What do y'all think we should do?
Subtract
the 2.
Since all I'm really doing, you can go -2, or I'll do the little arrow, which just means move that 2 over and change the sign. So we have 6a squared plus a minus 2 equals 0. You know, I think it's easier when that second sign is plus.
Have y'all figured that out? The second sign plus, it's easier. You definitely know what the signs are going to be inside those parentheses. If the second sign's plus, you have 2 of the first signs. But if the second sign's a minus, what do you have?
A plus and a minus.
Who knows? You may wind up with the minus in the first one, or you may have a plus in the first one. So I prefer it when that second sign's a plus.
Well, let's see.
I like the fact that for 2, there's only one possibility. 1 times 2, that's something, right?
So we said that there's a plus and a minus. Second sign is negative, so 1 plus, 1 minus.
What do y'all want to try? 2 and 3, or 2 and 3? Well, if we're going to try 2 and 3, don't write anything, Tony. If we're going to try 2A and 3A, where are we going to put the 2A? The first or the second? The first. You cannot put it in the second because you can't have that same number. 2 and 2 are both divisible by 2.
2A, 3A. Oh. Let's see, I'd have a 4A and a 3A.
What do we need that to equal?
Okay.
Okay.
I'm going to write plus 1A. So, we're subtracting these numbers. Remember that second? Where's that little table? My world famous table. Second sign is minus. 1 plus and 1 minus. Wait to fill it in. Subtract the outer and inner to get the middle. So if I subtract 3 and 4, I can get a 1. How should I arrange the signs? Should the 4, looking at these, the 4 and 3, to get a positive 1, 4 is positive, 3 is negative.
So what should go in front of that 1, a plus or a minus? A minus to get the negative 3A. Okay.
No, you're just making these work out.
Exactly. That's exactly what we're doing. That's a very intelligent statement.
Mm-hmm. I'm going to remember that. 31 years later, here I am talking about that student saying, and he didn't say it in a nice way, okay? I was young, and back then, it just, I feel sorry for the young teachers. Having been there and done that, so they don't get respect and stuff, But who knows? I may have hostile students. Are there any hostile students out there right now? Because if so, you're doing a good job hiding it.
Your hostility.
Okay?
You just keep that up.
If you are, then you're the type of hostile student I like, okay? So
I'm going to let him tell me, what am I going to do first to solve this? What am I going to do first? Okay, plus 1, so that becomes 2A equals
0 plus 1 is 1.
Okay. And then what am I going to do? Divide by 2 to give us A equals. Okay, there's one of my solutions.
What
am I going to do here?
Okay, subtract the 2. This time, instead of saying minus 2, I'll put the little arrow.
And then divide by 3.
So, negative 2 over 3. And a 1 over 2. Oh, why am I writing so messy? 1/2 and a negative 2/3. I'm going to try to punch that in.
Over here. I'm going to try to punch it in, Tony. Yes. And notice once again, the way they're trying to remind you, this isn't a factor problem. Variable equals. That's when you get the variable by itself. So you're going to have to use a comma to separate your answers. You have 1/2, 1/2. How many of y'all just do the slash the way I did from the keyboard? How many do the fraction bar?
Well,
okay, it's like the slash. Okay, you see, here's one thing you don't want to do. Comma. What's wrong with that? The comma is in the denominator, and some programmer that must have had a new programmer for Pearson was obviously had some free time, and so he went through on certain problems and he changed the code. So if you put the comma in the denominator, it still counted it right. But with what we're going to be doing with interval notation, you put a comma in a denominator, it is wrong. So even though some problems may accept that comma in that denominator, make a habit not to do that. Do the right arrow, click with your mouse, do whatever you need to do to get out from under that denominator, and then type your comma. And what was the other answer? Negative 2 over 3.
But for some of them, even before interval notation. If you have the comma down in the bottom, it'll count it wrong. So,
But there are a few problems where,
it'll
they take it.
Okay.
I know the programmer must have thought he was doing a favor for students, but no, not really.
Because
Used to be able, I could tell people, never put a comma in the denominator, they'll count it wrong. Well, now, most of the time, if you put the comma in the denominator, it'll be wrong, but there are a few where it does accept it.
and that sort of gives you the wrong idea.
Mm-hmm.
Let's do number 14, just because we have time.
Oh, yeah. Okay, I'm all in favor of that. Ooh.
18
18v squared minus 33v plus 14
Oh, well, at least there's a
equals
plus.
0. Yeah, you're right. At least it's a plus. Now, why do I say at least it's a plus? Okay, you know what the signs are going to be. You don't have to wonder, well, where does the plus go? Where does the minus go? What am I going to have inside those parentheses? Okay, two of the first sign, negative and negative. Let me switch over to the paper.
Okay. Numbers that multiply together to give 18. There's 1 times 18, 2 and 9, 3 and 6. Numbers that multiply together to give 14. 1 and 14, 2 and 7.
I think in this case, we're going to be able to take advantage of the fact that we can't have two even numbers in the same parentheses. Every pair here has an even number attached to it. So remember, we can't have two even numbers inside a set of parentheses. We already know the signs.
Second sign is plus. 2 of the first sign. And,
Now I'll let y'all just tell us what you want to do.
yeah, do I want to try the 3, 6? There's nothing that guarantees that'll work. Hopefully problem 6 convinced you of that. But I'll just try the 3 and 6. If this number here, the middle term, had been really big, I would have tried some of the bigger numbers, maybe.
The thing with the 18 and the 14.
But it's not. So 3, 6, 2, 7. The 2 can't be with the 6. And this might not. Is this going to do it? I don't know.
Oh, I think it is. But I didn't think that was going to work. I thought we were going to have to use the 2 and 9. So
I don't know what I was thinking. I was thinking 2 and 9 was going to do it.
Uh-huh.
And now I think 9 times 7. What the heck was I thinking?
I don't know.
But I think that's factored correctly. Let me see. Now, by the way, when I just said I think that's factored correctly, sometimes when I use the word I think, or if I seem uncertain about stuff, research shows that if you hear someone saying I think, or they seem uncertain, that most brains will start trying to figure out, is that right? So if I say, I think, if I seem uncertain, your brain is trying to figure out, is that right? Most brains. Okay, so there might be times this semester, and Tim used to never show uncertainty when he was up here, but he does now after listening
because
to
it's on his brain.
Research. I didn't conduct the research. I read about it, and it made sense.
I used to tell the class, I think it should be this, and people might disagree with me, and I'd have to tell them, listen, I'm going to let you in on a secret. If I say I think blah, 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 that means I'm 100% confident that it's correct. But
still. So, is that right? Did I
that
get
what
that
you need?
factored? Am I finished, or do I need to do something else?
You have to
Solve it. I thought he said stop. That's why. I was about to begin.
I was going to go back over here. Back over here. Look at what the answer. Variable equals. Okay, so. Wait a minute. Let me switch back to your writing.
So move the 2, divide by 3. So we have 3b equals 2 Divide by 3, so 2 over 3. By the way, if there's any color I use that you can't see, let me know. I know a lot of people have trouble seeing red.
It just shows.
And
up
I'm still
so well.
using red,
I
but
know.
it just shows up so well for. But if there's any color here, if you have a hard time reading red, just let me know, and I'll stop using it. So 2 over 3 and 7 over 6.
So 2 over 3, comma.
No.
No, okay. I'm curious if this is one of the ones where the little programmer trying to impress his boss spent the weekend, doing. Pearson used to advertise that all the programming was done in the U.S. I wonder if it still is. You see, they took it. When we're writing in the next assignment, and with interval notation, you put a comma in a denominator wrong, and it doesn't say, hey, check that comma. Nope, it just wrong. So it really didn't do you a favor there.
I think we've done enough for today. Any questions? So we factored and we solved. There's a difference. Those instructions are kind of important, okay?
And the way
you've
they
got to
have-
sort of recognize it. You get the variable equal when there's an equal sign in the original problem. Okay? So, any questions? If you have any trouble logging into or getting started, we have plenty of time right now. We can help you with that. Okay? Why don't you go ahead and stop recording now?